All right, ladies and gentlemen. So, in this week, this will be the final week of this chapter, and we will move on. Um, Basically, one of the reasons why I'm kind of redoing some of this is number one, or re-reviewing this because I kind of had planned on doing the test and then moving on. It's because I do still feel that many of you are not watching these. I'm going to send a message to everybody, making sure that you're doing so. But it's really, really important. I'm seeing people making a lot of silly mistakes, not doing what it is that you're supposed to be doing. Um, the purpose of the videos is to show you how to do. I mean, I'm literally doing problems exactly like I'm expecting you to do. So what you can do is you can watch the video for number one, pause it, go look at number one, and then do it exactly as I did it, step by step. You can watch number one. Okay, I know how to do it. Go back, pause it, and then even restart the video and watch me do number one. And you do your number one the same way I'm doing my number one. That's really the purpose of these videos. It can be as easy as that. Um, but your work should look exactly like my work. Your explanation should be very similar to mine. I'm not even looking for you to give me masterful explanations. As long as it looks a little bit like mine, I don't even care if you take mine and simplify it, but it needs to be, your explanations need to be the same. Now, this video, besides this explanation, that explanation I just gave you is going to be very quick because this stuff, day one, is the stuff that I think you're good at so far. But I did want to go over one thing. For the exponential versus linear, you guys are very good with the graphs and even the equations now. After a couple weeks, the graphs, obviously, straight line, linear, curved, exponential. With the equations, as you guys have gotten better at it, exponential, you're looking for an exponent. Is there something to an exponent? If there is, it's exponential. If there's no exponent, everything's on that level, the level with the numbers, it's linear. The tables, I'm still seeing people making mistakes. What you need to do is, first off, check the x's. This is the only thing you need to do with the x. Look at the x's. 0, 1, 2, 3. If it's going by ones, it's going consistent. That's all you need to check. The most important thing is the y's. And what you need to do is, what is the change in the y? So from this first y4 to the next one, what happened? We went down 2. I don't even care if you put a minus or a plus. The difference is 2. Let's go to the next one. The difference is from 2 to 1 is 1. Difference from 1 to a half is, well, 1/2. The difference from 1/2 to 1/4 is 1/4. You probably won't even have to deal with fractions, but the thing is what you're looking for is, if it's the same every time you do this, then it is linear. If it's different, then it's exponential, as long as the x is going by 1, and it is. So here they're different, it's going to be exponential. And this is the work I'm expecting you to do, so you're getting answers here, folks. But for every graph, you need to do that. Now, be careful, because I did want to give you this example. The x's, they're going at different intervals. This one's going by 2, this one's going by 4, and this one's going by 1. Now, the only reason that's important, that's not going to happen very often, is it's just something you have to pay attention to, because here's what's going to happen. What's the difference from 14 to 6? Well, it's 8, right? We went down 8. From 6 to 10, we went down 16. And then from 10 to 14, we went down 4. Now, those look like they're different on the y. Here's the issue. They're different on the x. If they were the same on the x and they were different, it would be exponential. This is going to be a little different. What's 8 divided by 2? You're going to take the interval 8 and divide it by 2. You get what? 4. 4. What's 16 divided by 4? It's 4. What's 4 divided by 1? 4. If the x's were going by 1, that means the y's would always be going by 4. So what I mean is, if it went -2, -1, 0, 1, 2, 3, 4, 5. -2 is 14. -1 would be 10. It is going by 4s. 0 is 6. Hey, because we're going down by 4. 1 would be 2. 2 would be -2. 3 would be -6. 4 would be -10. 5 would be negative 14. So just be careful. If we fill it in, you notice, hey, it's going by 4. So this is actually linear. So just be careful there. It's not always going to be you're looking for the y. That's why I gave you this example. But if you fill in the gaps, you notice, hey, it is going by 4. So it is, in fact, linear. All right, so just be careful. So if the y, as long as the x is going by the same thing, if the y is going by the same thing, linear. If the x's are going by 1 and the y's are going by different things, it's exponential. All right, scientific notation, not a whole lot to say. This is actually something you guys are very good at. I don't see a lot of mistakes here. Just keep in mind, if it's a small number, like this, a decimal, if it's a decimal, when I say small number, I mean decimal, your scientific notation is going to have a negative exponent. Going to have a negative. If it's a really big number and you're putting it in scientific notation, it's going to be a positive exponent. The other thing to keep in mind is if you notice down here, the decimal is always 1 away from, there's always one number in front of the decimal. That's where you want the decimal. So for this one, you'd only move it 2 to get that decimal there. This one, you'd move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Move it 13 to get it right there. And so then vice versa, if your exponent is negative, you're going to go the opposite way, and it's going to be a small number. So for this negative 4 right here that I'm circling with the eraser, it's going to be a small number. It's going to be a decimal, and then the big one is going to be a big number. All right, guys, that's it.